ップルラインです。アップルライン近く。
You're copying what the STL does. You will write two assignment operators. You will write a copy and a move separately, even though they probably end up doing mostly the same thing. But if you don't care about exactly following what the STL does, and you just want to get the code done, I would consider writing just a by-value assignment operator. I don't see anything wrong with it. Right? So this leads us to what's been called the rule and a half. So your class director manages some kind of resource. You may need to handwrite 4 special member functions. The instructor, the copy constructor, the move constructor, and rather than 2 assignment operators, it would be fine to just write 1 by-value assignment operator to create a left-hand resource and then transfer ownership from the right-hand by-value argument. You got it by value. It's a local variable view. You know nobody else cares. To implement move assignment. Right? Because if you don't, then when you try to swap 2 things, you're going to get either a compiler error or it's going to call std swap. And what does std swap do? It calls your move constructor, and then it calls your move assignment operator, and then it calls your move assignment operator again. And if your move assignment operator is implemented in terms of swap, and it calls std swap, and std swap calls your move assignment operator, you're going to have a bad time. So that's why if you're going to use the copy and swap idiom, I strongly recommend you write a swap function.
Would there be any gotchas by leaving out the R value ref overload operator? Would there be any gotchas with the compiler looking for that in cases of like return value optimization? Would you be missing out on that potentially?
So the assignment operators have anything to do with return value optimization. That would look for constructors, not assignment operators, because it would be creating the return slot value. I had a whole talk I gave last year, much too fast on RPO, which I recommend. But you could leave the move assignment operator out entirely, and then overload resolution would pretty much always have to prefer the copy assignment operator because it was the only assignment operator you wrote. And that would be fine, possibly a little less efficient. And if you were writing something like unique footer or unique block that you didn't want to be copyable, then obviously you should delete the copy assignment operator and write a move assignment operator. But there's no problem if you omit this. Overload resolution should do the right thing and just get extra copies. Yeah.
Does the logic for only writing 1 assignment operator, could that apply to the constructor too?
Could I make a by-value constructor? No. The compiler will not let you do that. In fact, it's not even like nonsense. Like literally there will be an error message if you try to make a constructor that takes by value, because how would you construct the parameter? Your by value parameter. You construct it using the by value constructor, which takes by value and needs to construct the parameter. Constructors. Right. Alright, so that was the rule of 4 1/2, where the half is the swap. So here's our no longer naive vector, or the rule of 4 1/2. This has no bugs that I am aware of. Not even calling the wrong delete. Correct. Alright. So here I have my vector, which would have a copy constructor. In the copy constructor, I am copying the resource. In fact, I'll put that up. The copy constructor, I'm copying the resource. The reason I need to copy the resource is to avoid double freeze. In my destructor, top of the right column, I'm freeing the resource. That avoids memory leaks, or resource leaks in general. In my move constructor, I am transferring ownership of the resource from the right-hand side into this object, the left-hand side. And I'm making sure that the right-hand side knows that it no longer manages the resource. I'm making sure that it's nulled out. It thinks its size is 0. It thinks it's in a good state. It's empty at this point. I also have this swap function at the bottom here. At the bottom left, I have my non-member swap. This is my argument-dependent lookup ADL overload of swap using something called the hidden friend idiom. I'm putting that friend function right in the body of my class, just marking it friend so that the compiler knows it's not a member. It is a non-member, takes 2 arguments. And all it needs to do is just call my member swap, which I also write. On the lower right-hand corner, I've got my single argument member swap function that swaps RHS with this. And it can do that member-wise, just swap the wire, swap the sizes, and it can be no except neither of those operations. Notice that my move constructor is also no except, and I did not mark my assignment operator as no except, but I certainly could have. I think the only reason I didn't is it didn't fit on the slide. But if I'm using the copy and swap idiom and I'm taking my value, then the only operation I do in this function is a swap, which is already no except, and I destroy my parameter, and destructors are no except, so this can't possibly throw either.
Question?
Yes.
So why did you make the 2-parameter swap a friend member instead of including it in
why did I make the 2-argument swap a friend instead of including it? You mean instead of making it a member?
Yes.
Well, if it were a non-static member function, then you'd have to call the 2-argument. You'd have to have an instance of naive vector, and then call dot swap, and then pass the 2 things you wanted to swap. And that's just not how the STL does things. And if it were a static member, you'd have to say vec : swap of those 2 things. Again, that's not what the STL is looking for. The STL is looking for a function named just swap in the same namespace as vector, and that's what this idiom does. Alright, so notice I've highlighted the places where we actually mess with the resource. Right, these are places where I'm hiding my manual resource management. In the copy constructor, I need to write code that explains to the computer how to copy this resource. Right, the human programmer knows how to copy it. This is where I put it in the copy constructor. That's where I put the code that copies the resource. In the move constructor, I need to explain how to transfer ownership of the resource. That's usually very mechanical. In this case, I'm just exchanging over the pointer, exchanging over the size, but it's still part of my programmer domain knowledge that null footer 0 is the appropriate representation of a move from vector and empty vector. Right? That gets it back in a good state. That's part of the information the computer doesn't already know. I need to communicate it. But my assignment operator and my non-vector swap, those are completely mechanical. They always look exactly the same. There's no special domain knowledge being encoded by the human there. But how to free the resource in the destructor at the top of the right column. Freeing the resource, that's again something that I have to communicate. This is how you free this resource. You call delete, you call close, right? You call mutex unlock, whatever it is. So the highlighted things are the bits of information I am putting into the program. The other stuff is the boilerplate that can always be the same. We can get closer to rule of 0, right? That was sort of a rule of 5 vector. I hand wrote all of those functions. But if I had managed the allocation using std_close, which is a resource management class that itself follows the rule of 5, then I wouldn't have to do quite so much. The transfer of ownership is now defaultable. So if I construct the vector, what does that mean? It means I will construct the unique footer, I will construct the size. I'm done. Ownership has been transferred by unique footers, move constructor. I've delegated that resource management responsibility down to unique footer. However, I still need to do something special. Right, unique footer is not copyable by design. I still need to do something special to swap ownership. Can't get rid of that. There's no way to equals default my swap. But that's a lot closer to rule of 0. That's a lot closer to what we should strive to write, even if we're something like vector, which admittedly is kind of a resource management class itself, but it's still able to delegate some of its responsibilities down to a simpler resource management class that's been written and tested by someone else and can take some of that thinking away from us. And a completely rule of 0 vector, of course, would just use std vector. Okay. If it uses std vector, not only will it be more efficient because it will do geometric resizing and be written by, people who write C++ standard libraries, but also it means now we can default all of my special members. Right? Here's my rule of 5. I've got my copy constructor, my move constructor, my operator, my move assignment operator, and my destructor, and I am explicitly defaulting all of them. Now, if I have multiple members and I am defaulting my assignment operators, the default assignment operator will do member-wise assignment. So that might affect default from slide 34, 36. So you might want to explicitly use copy and swap in that case anyway. It wouldn't be wrong. And again, I'm writing a swap function. Yeah.
So the problem, I'm always trying to get to rule of 0, but then I find when I don't have a constructor, like how do I get my members initialized? Is it via putters? Then you got to set or setters that you construct it with a default constructor, and then you got to turn around and go set, which.
So if I'm striving for rule of 0, and I'm defaulting all of my special members, I've got my defaulted constructor as well. Does that mean I can't write any other constructors because I would have to write bodies for them, and that violates the rule of 0? No, that does not violate the rule of 0. So it's about these 5, and maybe the default constructor, maybe. But you can totally have other constructors. I mean, that is not in any way a double violation of the rule. I can have a constructor that takes an initializer list of ints. I can have a constructor that takes a single int and resizes to that size. Like a constructor that takes an allocator or whatever. Those are not special member functions except in that they're constructors. But you always need some way to construct your object. Right? Rule of 0 is about these resource management functions. The structure, the copy constructor, about resource management, not about how do I construct things. It's not saying you just have a default constructor and that's it. You can definitely have other constructors. So to finish up here, we have about 10 minutes left, and I just wanted to give some examples of resource management. So here's one example I'm going to in this format. Unique footer. Unique footer is an RAI class that follows the principles of RAII, and it manages a raw pointer owned heap allocation. So what does that mean, a uniquely owned heap allocation? Well, to free a resource, to free a heap allocation, we call delete on the pointer that's managed. Unique footer. Copy constructor copies the resource. What does it mean to copy a unique heap allocation? Well, it might mean to make another heap allocation. In this case, that's silly. What we're managing here is not the allocation, it's ownership of the allocation. Okay? So you can't copy ownership. Ownership is by definition. So copy doesn't make sense. We equals delete the copy constructor on unique footer. Move constructor transfers ownership, making sure to null out the right side so that it knows it's no longer responsible for ownership. Copy assignment, well, copying doesn't make sense, so we equals delete it. And move assignment frees up source and transfers ownership of the right-hand one. And so it has 2 responsibilities. It needs to not just transfer the right-hand pointer and null it out, but also make sure that it's calling delete on the left-hand pointer, the original value. Right? Assignment has 2 responsibilities, which again we're mostly mechanically doing by doing copy swap. We didn't really have to think about them. But if you are thinking about them, remember assignment has 2 responsibilities: free the resource and transfer or copy the right resource. Shared footer manages a reference count, 1 increment of the reference count. So the destructor frees the resource. It means to free a reference count, it means to decrement the ref count, and if the ref count was 0, you need to clean up the object. Copy constructor copies the resource. What does it mean to copy an incremented ref count? It means to increment the ref count a second time. So that's what the copy constructor of shared footer needs to do. Move constructor just needs to leave. Also be in an empty state, disengaged. The move constructor vector transfers ownership of a unique lock. So that means leave the mutex in whatever state it's in, right? Don't lock or unlock at all, just transfer ownership of the lock, and indicate to the right-hand side, to the right-hand unique lock, that it is no longer responsible for unlocking that mutex into a disengaged state, an empty state. That means that the destructor, when I destroy the right-hand side, is not going to unlock the mutex prematurely. An IF stream manages a file handle and an associated buffer. So it has a destructor that calls close on the handle, on the file handle. It has a copy constructor that copies the resource. Well, actually, it doesn't. The standard IF stream does copy an IF stream. We could imagine maybe doing something to duplicate the file handle and giving a copy of fresh buffer. We wouldn't want to copy the buffered out when you would print out Hello World and it's been buffered and it hasn't yet gone to a disk or screen or wherever it was going, and then you copy the stream. You wouldn't want to also copy the buffer because then you have two Hello Worlds eventually making it out the screen. That's part of your human domain knowledge that you know about what it means to copy an IF stream or to copy, your custom stream class with a buffer. So that's part of what you would need to communicate to the computer by putting it into the copy constructor. Move constructor of IF stream transfers ownership of the stream, and then copy assignment operator on IF stream is deleted. Move assignment operator would close the left-hand stream, flush the buffer, close the stream, transfer ownership. So all these transfer ownerships, especially for unique lock, I made a big deal about the empty state, the disengaged state. So in each of the preceding examples, also unique pointer, also shared pointer, there was a move operation that involved disengaging the right-hand side, calling out the right side, so that the right-hand side knew that it was no longer responsible for cleanup. So if you have a move operation and you're going to filter the of this class such that it no longer has its responsibility that it used to have, it also needs to have an empty state, a responsibility-free state, a carefree, doesn't need to do anything. But you can do RAI without this empty state, right? Without optimization. The optimization helps performance, but you can do RAI with just the rule of 3. That's how we did it for decades. And you can even do RAI with only destroy, with equals deleted, copy operations and move operations, where all you can do with the object is create it and destroy it. We saw a poor example here with our RAI that we used in the exception safety example. Alright, delete your copy move operations, and there is at least one standard class that behaves that way. It's called lock guard, and it takes a lock on a mutex, and then its destructor unlocks the mutex. It doesn't have copy or move operations. It just clicks on the stack, and that's all it does. You make one, you destroy it. That's it. That's still RAI. Let's look for questions. Thank you.
Technical computation. Okay. So your copy. There is a copy that is done.
In my assignment operator, I could put no except because I'm not the topic. My caller is the one doing the copy, and it might not be a copy. It might be a move. Okay. All they have to do is get me a vector somehow, and that's not my responsibility. My responsibilities are just swapping and destroying, which are both no except, so I could put no except in this case. If I had written a custom copy assignment operator that took a construct, I mean, the first thing I did was copy constructor, then yeah, I can flip around. Yes.
So object, I'm strictly following the rule of 3, and I default the 2 move operations. If I assign my object to an RBEG, will it mess up? It's called defaulted 1, or it's going to call the rule of 3 that I next implemented. And as a follow-up, will it behave differently if I do not default the move operations?
Alright, if an object that follows the rule of 3, so you have you can throw a destructor that actually does something, and a copy constructor that actually does something, and then additionally you equals your move operations, that is almost certainly a bug. The equals defaulted move operations is again local reasoning. So the compiler sees the defaulted move operation and will say, okay, I'll use this move for that. That's almost certainly wrong for your use case, because it probably isn't going to null out the right-hand side. You'll probably end up with some double freeze in that case. If you don't write any move operations, you don't equals delete or equals default them, then they will not exist by default. The rules for, like, if you default this one, then this one gets implicitly also defaulted, and if you delete this one gets implicitly there and all, which is somehow different from deleted, are fairly complex. There is a table going around that Howard Hinnon made several years ago, showing, like, 6 columns and 7 rows, something like that, and says, like, if you default these ones, then these become deleted, things like that. So the rules are complicated, but essentially, short answer to your first question, but yeah, that's totally a bug, don't do that.
I just follow that up with another. Would it be safe to say, by the way you just said, that when you're following the rule of 3, there would A, be no harm, and B, maybe some clarity benefit to always eating the 2 move, special number functions?
Unfortunately, no. That would not be right. Because if I'm following the rule of 3, so I have my copy constructor, let's say, and then I made a move constructor that was explicitly deleted. What it means is that you can construct instances of naive vector out of L-value naive vectors, but if you try to construct a naive out of an R-value naive vector, you get a compiler error. It would say that overload of the constructor has been deleted, you're not allowed to move it. And that's what you want. What you want is for move to quietly degrade down to copy. And the way you do that is you just don't write anything for your constructor, which makes it not exist, which, as I said, is something different from being deleted. Thank you. That's very clear. What this does mean is that if you have C++ 9803 code that follows the rule of 3, and you upgrade your, and you pass C++ 11, it will just keep working. It won't quietly break, it'll keep working.
And what do you think that the STL doesn't make use of native code? Do you propose the doesn't by value, and then again there's no native to the code?
Why doesn't the STL use by value
And of course, my computer went just to sleep there, didn't it? So we want to talk about, specifically,
vidéo dure à dire.
protocols which are used in distributed systems. And one particular protocol, which is SWIP. So the title of this talk was from the first photocopy to modern failure detection in distributed systems. And you're probably sort of thinking, well, what's a photocopy got to do with a distributed system? Well, not so much a photocopy, but a photocopier company. Slightly misleading, I admit. But the key thing is that back in the 1980s, Xerox were looking at the future of technology. They were looking at a lot of the systems that were up and coming. So anybody use a mouse? Everybody, right. Xerox. But one of the other things they were looking at is this incredibly futuristic tech called email. And specifically with email, what they discovered was that if you want to be able to distribute email across the globe, across multiple networks, a single email server isn't going to cut it. So it was quite logical to use replicated email servers. The problem with that is that they've got to replicate the data.
駅までいくらです
Xerox
か
discovered that replicating this data wasn't actually that easy.
駅
They took a couple of different approaches. They tried just multicasting the data.
あ、これ
They tried using sort of anti-entropy techniques,
ありがとうございます
replicating select data between servers, and none of this really cut it. What this led to was this seminal paper. So in 1989, Academic Algorithms for Replicated Database Maintenance. And this was by Alan Dennison and co. And what this set out was a way of managing this kind of replicated data, but using an epidemic or a viral type of an approach. So in the paper, what they did was they looked at a couple of different methods, and they analyzed the kind of direct mail approach. So every time an email server received an email, they would forward it on to all of the other servers. But the problem with that was that some servers didn't know the locations of the other servers. Sometimes messages would get lost. It was relatively efficient, but it wasn't particularly reliable. And I mentioned anti-entropy before, but they took this anti-entropy approach. So at a sort of an irregular time period, one of the servers would choose another one at random, and they'd sort of sync their databases. They try and do a diff between their two data stores. And this proved pretty efficient. It was sort of very efficient at managing to kind of get this data replicated across the systems. But the problem with it was that it was slow. You could only sort of do this anti-entropy process at quite long intervals, and that meant that propagating these emails across this geo-distributed network didn't work so well. And the last approach was rumor mongering, or gossip. And this is when one of the servers receives a new message, it treats it like a hot rumor. So it will then pick another server at random, and it will forward that message to it. Then the servers would do another send, and they would just keep propagating these messages right the way around the kind of the cluster in the same way as you would spread a rumor amongst your friends. And this proved really efficient. It was also very effective. Now, that kind of gossip